Okay, a bat uses sound waves to avoid flying into objects. A sound wave travels at 342 meters per second. The time for sound wave to reach to several objects and return to the bat is shown below. Okay, so tree 0.1, 0.25. So the longer the time, the further away it is. This is really small, so cliff wall must be very close. Okay. Okay, so what we're trying to get a relation is between how long, the distance between the object and how long it takes. Okay, so that's the direct relationship. It's a direct variation between distance and how long it takes. Now, how long it takes, right? The rate of change is given to be 342. That's how fast the speed is. So that's going to be our slope. Okay, and note that the unit for this is meters, right? This is seconds. So if you just divide both sides by t, you get d over t. And you know that 342 is meters per second, and that's distance over time. Okay, so that's our equation. Now for the distance, you just have to plug in 0.1. 342 times 0.1 will give you 34.2. Next one is 342 times by 0.25. That's same as dividing it by 4. Just reduce top and bottom by 2. You get 271 over 2. That's 135.5. Hopefully I did that correctly. And lastly, 342 times by 0.04. So if I actually multiply this by 0.01, I get 3.42. But 0.04 is 4 times 0.01. Okay, and let's multiply that by 4. Okay, there it is. So that's how far the actual objects are for these times. Okay, I missed a minor detail here. This time given is total time it takes to travel to the object and come back to the bat. So the actual time it takes for the sound to reach the tree must be only half of this time, right? So 0.1 second is to go to the tree and come back. Okay, so since distance is time times by 342, all of these numbers have to be divided by 2. Okay, so let's divide that by 2. You get 7.1. Divide this by 2, right? You get 7.75. Divide that by 2, 684. So that's the distance. Okay, so I just divided all the distance by 2.